Hello all, I am Ranjan Gupta. I am from Electrical Department, third year, 2025 batch. And we have made a project about the weather satellite tracking system. This is a real hardware prototyping of a real-time weather satellite tracking system, where in this contraption you can see that is the current data that we are having right now. And if we want to see how the project actually works, you can see the whole mechanical construction, where we have two motors that actuates this antenna, this axis that is there with the main antenna. This is a 137 megahertz Yagi UDA antenna. There is the two dipoles that are connected through this SMA connector and going into the coaxial cable and going into the software defined radio right over the computer. And we can see the direct data is coming right now. And you can see in this system the whole contraption is moving in a arbitrary or way with incremental azimuth and elevation values just for demo purpose. But in actuality, what this does is this will track the special satellites that we have programmed in our computer. That is the NOAA series satellites, especially NOAA 18, NOAA 15, and NOAA 19. Those satellites are actually NASA have already launched in 19 something years. They have passed their lifespan, and they still transmit weather update images. They just scan the area and direct transmit the picture through APT module, APT type of signal. And through narrowband modulation they transmit around 137 megahertz band, VHF band, and we receive the data as audio format, and then we post process the data. If I can show you the data, how the data actually looks like, there you can see the whole interface there. This is the pattern that the software defined radio sees, and there you can see the satellite position that it tracks. And this is the data is directly pipelined to a different software, which is then decode the audiometric data, which is APT kind of format, automatic picture transmission format. It's there is a bandwidth, and in this bandwidth the audiometric tone of different frequencies are being transmitted from the satellite, and we can then decode the data and then get the image. So this is the circuit, the schematic of the project. This whole project is inspired by one of the website that you can search on, the SARCnet rotator MK1. It's kind of same, but we have manipulated a lot of things. We have also coded a lot of things in order to drive the overall rotor system as well as live tracking. So in this picture you can see the data, how the data actually looks like after decoding the data. And this is your calibration marks, and through that you can reference the pixel density, and you can then filter it out for the cloud formation or rain mapping or temperature or whatever. So this is some of the pictures that we have taken previously. And there is a different filters that is being applied for mapping of different weather situations. Those are taken quite recently. And the whole system, you can see the polar orbiting satellites. Those are actually polar orbiting satellites that maneuvers around our earth. So it's a different thing. You can also search this on our YouTube playlist. It's a step-by-step process of making the whole project. So right here, if we can see if you can see the whole overall project, the rotator actually works by this 3-axis gyro as well as accelerometer plus magnetometer that is mounted over the axis of the antenna, and from there we have communicating with the main our AVR, that is then give the position data to the AVR, and that consistently control the position of the antenna. So we can directly access the serial uh, port of the AVR, and we can drive the overall structure. So if we come here to the receiving system, that you can see this is the live feed that is coming from the software defined radio, and this is the decoded image of one of our pictures that we have already taken. And you can see you can apply different kind of filters to it in order to get different data. So this is right now processing. So let me show you a different thing. So this is right now, the timing is actually wrong, but this is actually showing the live position of a particular satellite, that is the NOAA 15. That is the current azimuth elevation angle with respect to this location. We can also get a lot of additional data from this kind of software. This is a software defined radio software that concludes all of this, but in our system we actually use the GPredict software, which is quite useful. It has a rotator control uh, built in, so through that we actually can track and rotate our antenna. There you can see different satellites are there. We can select and we can track any particular satellite if we want. There's a lots of satellites are maneuvering right now, and that is our position. And if we want to get the this kind of data that we get, actually the cloud formation, there you can see. So that's it for this demonstration of our overall project, the weather satellite tracking system. This is a hardware prototype model. So thank you.